500 Newton object is to be given an acceleration of 0.40 meter per second square. How large must be the applied force if the coefficient of friction is 0.20? Let's write first are given together with the free body diagram. So if we're going to draw our free body diagram, this is how it will look like. So we have here the normal force, and we also have the weight. And take note that the weight is 500 Newton. Now, based on this idea, we could simply get the mass. And to get the mass, that is weight divided by 9.8 meter per second square. And therefore, the weight is 51.02 kilogram, or rather the mass. So the mass is 51.02 kilograms, and the weight is 500 Newton. Now we also have the value, which is the F up, and we also have this frictional force, and the other given, we have the coefficient of kinetic friction, which is 0.20, and the value of acceleration as it travels in the right direction is 0.40 meter per second square. Now, what is the required? The required is simply the applied force that is needed in order for us to accelerate that 500 Newton object. So let's try to write now the summation of Fx. Remember that the summation of Fx is equals to mass multiplied to the acceleration in the x component. So getting now the value of all the Fx, we have there the F up and the frictional force. So we could write our equation as F up minus the frictional force, minus simply because it is in the opposite side, and mass multiplied to the acceleration in the x-axis. And we have the value of Ax, which is 0.4 meter per second square. So let's try to substitute now. So we could have here F up, which is actually the required, minus the F is equals to the value of mass, which is 51.02 kilograms, multiplied to the acceleration, which is 0.40 meter per second square. Now, as you can see, we have these two unknowns. We have this F up, but we also need to know the F, or the frictional force. Is there a way for us to get the F? Let's write now the summation of Fy. We have here the mass multiplied in the acceleration in the y-axis. However, do we have the value of Ay? Is the box moving up or down? Simply it is no. So therefore, your Ay is 0. So we can say that the summation of Fy is 0. Now, what are the components of our Fy? Our components of our Fy is the normal force minus the weight, since the force is pointing downward, equals to 0. And the normal force is unknown minus the weight, which is 500 Newton, equals to 0. Therefore, the normal force is 500 Newton. Now, let's try to look at the following equations. We have the first equation wherein the F net is equals to mass times the acceleration, and we did it already by getting the summation of Fx and the summation of Fy. And we also have this equation, which is the frictional force equals to coefficient of kinetic multiplied to the normal force. And let's try to look on this aspect wherein the F up minus the F equals to 51.02 multiplied to 0.40 meter per second. So we could predict that the value of F can be solved, which is the coefficient of kinetic multiplied to 500 Newton. So solving for it, we have now coefficient of kinetic friction, that is 0.20, which is a unit less, and Newton, we have the normal force, we have this 500 Newton, and 0.20 multiplied to 500, that is 100 Newton. And this is the value of our frictional force. Now, going back to our equation, which is this, we can simply solve now for the value of the F up. So let's do it again. So we have the F up minus the frictional force equals 51.02 multiplied to 0.40 meter per second square, that is 20.408 Newton. And then since we have here the F up minus the frictional force of 100 Newton equals to 20.408 Newton, deriving now for F up, that is 20.408 Newton plus 100 Newton. So you have to transfer this 100 Newton to the other side, and therefore the value of F up is 120.408 or 120 Newton.